All right, so this is our last session before the summer.
Yes, yeah, it is.
When is your final? Is it tomorrow?
I already took my final, but I have another quiz in the class on Thursday.
Okay. All right, so what are we going to do tonight?
Just more of the algebra review stuff. I've got problems on my other computer right here, so.
Okay. Let's have them.
So the first one is find the solutions of 6x squared minus 6x minus 2 equals 0.
First step.
Factor.
Okay. Well, what kind of factor?
Factor out the greatest common factor.
Okay. So what is that?
It's 2. So it's 2 times 3x squared minus 3x minus 1 equals 0.
That's an important step because that's going to be a much easier quadratic to factor, I suspect, than the original. It's always easier if it's simplified. Because, for one thing, I can just cross out that 2. I can divide both sides by 2.
Right.
Now, it doesn't take very long to see that this does not factor very well.
Right.
In other words, there's not many ways to factor 3x squared, and there's not many ways to factor 1. None of the combinations are going to produce this middle term. And that's always the key. You always are trying to produce the middle term. So immediately we know that we cannot factor it, but we can still plug it into what?
The quadratic formula.
Which is?
B, or x equals b.
It's minus b.
Minus b plus or minus the square root of b squared plus 4ac.
Minus 4ac.
Minus.
It's okay. At least we know you have a... we know what your leak is. Go ahead. I'm an ex-poker. I'm an ex-poker player. In other words, your leak is leaving out the minus sign. Okay. Now, so what does that x become?
Becomes 3 plus or minus the square root of 9 minus 4 times 3 times negative 1.
I definitely suggest you write it exactly like that. In other words, you never ever try to do that step in your head.
Right.
And the reason is it's so easy to make a mistake with the sign. All over what?
2 times 6.
Okay. I don't mind doing those steps in your head. Now simplify. And always simplify what's in the radical sign first. In other words, don't do more than this step. What is, and in fact, when you go to figure out what the discriminant is, I suggest everybody always do that step first. In other words, it's very helpful if you follow a standard pattern to avoid mistakes. Okay? So, what's that whole thing equal to? What's the discriminant equal to?
21.
Okay. Now, simplify that. It doesn't simplify.
Yeah. Okay.
Okay. Now, at this point, you can leave, that's pretty much the answer. In other words, square root of 21 simplifies to root 7 times root 3. But that doesn't help. It makes 2 terms instead of 1. So that means it doesn't simplify. Okay? Now, I do have some choices here. I could say this. You see why that's the same?
Okay, yeah.
So all I've done is separate it into 2 fractions. And the only reason I would do that is because I can turn that into a 1/2.
Right.
Whether or not, I doubt that they would ever do that. If they were going to give you like a multiple choice test, my guess is that one of the answers would be that right there. Not this. It's important to understand they're the same thing, but are your tests multiple choice?
Yeah, this next quiz is multiple choice.
Okay. Or your next quiz? Yeah. All right. What else you have, William?
So, solve the equation.
Okay.
It's 2x squared plus 6x minus 2.
Sounds like your allergies are better today.
I feel a little better.
A little bit, yeah. No, I can recognize the difference. I'm very sensitive to it because I suffer from them myself. And mine are a lot better. The last 2 or 3 days, mine have improved a lot. I think my allergy season is pretty much over. Right.
Yeah,
so
I don't take meds because I'll be like this for 5 days out of the year, and then the rest I'm totally fine.
Ah, okay. All right.
It's really weird.
Yeah. There are some meds like Claritin 12-hour non-drowsy that have pretty much no side effects, and they work really good against allergies if you want to look at that one. That's what I use, and I love it because it doesn't make me sleepy.
Yeah.
So what's the first step here?
Factor out at 2.
Which gives me x squared plus 3x minus 1 equals 0. Skipping 1 step.
Right.
Again, doesn't factor. No way am I ever producing 3x in the middle.
Right.
So I got to use the quadratic. And the next question you might have, well, if I got to use the quadratic anyway, why don't I just start from there? And my answer would be the same. In other words, I can use the original function and use the quadratic. In other words, x equal minus 6 plus or minus the square root of 36 minus 4 times 2 times minus 2. But notice my numbers are all bigger. Whereas if I use the quadratic on this, I'm already simplifying it before I even begin. You know what I'm saying?
Right. Yeah.
I would rather deal with this than with this.
Right.
The top one, everything is double. So that's why I factor out the greatest common factor. That's always my first step, is to factor out the greatest common factor. Always. Even if the thing factors beautifully, I factor out the greatest common factor. Okay?
Okay.
And we don't want to do all that. It's much harder arithmetic. It's going to give you the same exact answer. But this is easier. What does this give us?
Negative 3 plus or minus the square root of 13 all over 2.
Okay. I think you know quadratic formula problems. What other stuff do you have? I mean, do you agree?
I do agree, yeah.
Okay, let's go on to something new.
Alright. Hold on, I'm sorry, my computer is once again being difficult.
Huh. What operating system do you have?
I've got, so right now I'm talking to you via our Mac, and then I've got my Windows Surface Pro with the problems on it.
Okay. I was curious because I had a student earlier today who was also having technical difficulties, and he had an older Windows operating system. And I was thinking, you know, there was a massive cyber attack about a week ago that attacked all old Windows operating systems.
Right.
As long as you had a newer version where you were getting updates, you were fine. But if you had something like Windows Vista or
XP, something like that.
Yeah, then because you hadn't probably been updating it, I don't even know if Windows makes updates for those anymore. But that's what that massive attack attacked, was those operating systems. It's the only reason I asked.
Okay. So the next ones I don't have actual problems for, but could I just ask you to clarify
Sure.
The characteristics between even and odd functions?
Yeah. The best example of an even function is this one. Notice the even exponent. Notice also that it's symmetrical about the y-axis, and that if, here, let me write it properly. Instead of y, it's much better to use f of x notation. And here's why. All even functions satisfy this property. So, if I go up and look at this function I'm looking at here, x squared, well, what is f of minus x? It's minus x in parentheses squared, which is equal to the original function. So that is satisfied. F of minus x is the same as f of x.
Okay.
Notice that f of 2 would be that value. F of minus 2 would be the same value on the y-axis. Odd. The best odd function is f of x equals x cubed. Notice the odd exponent.
Okay.
Now, what odd functions have in common is that f of minus x is always equal to minus f of x. Notice the difference. This one, f of minus x is equal to f of x. This one, f of minus x is equal to minus f of x. If I graph f of x equal x cubed, I get that, which is symmetry about the origin. Even functions, symmetry about y, axis. Odd functions, symmetry about not the x-axis, but the origin. And what does symmetry about the origin mean? It means if I take this part of the curve and I reflect it over y and then x, I get that. So symmetry about the origin is really a reflection over both axes. there is no symmetry about the x-axis for a function. Notice that if I had symmetry about an x-axis, it would have to look something like this. Well, that does not pass the vertical line test. Boom. That's not a function. So you cannot have symmetry about the x-axis for a function. You can have it for lots of things. You can have it for a parabola, like that. Or you can have it for a circle like that, or an ellipse like that. Those all have symmetry about the x-axis, but none of them are functions. So if I'm talking about a function being odd or even, then its symmetry has to be either about the y-axis or about the origin. Okay? And so you're looking for stuff like that. This is the clad iron test for odd or even functions. So let me give you some. You tell me whether they're odd or even. There's three answers. There's odd, there's even, and there's neither.
Okay.
So, what's the first thing you need to do?
Find the parent function?
Nope. It's to figure out what f of minus x is. Remember, that's the ironclad test for even or odd. It's if f of minus x is equal to f of x, then it's even. If f of minus x is equal to minus f of x, then it's odd. And if it's not equal to either one of those, it's neither. Three choices only. So tell me what f of minus x is equal to.
Minus x minus 1 squared.
Now, let's go ahead and square that, just so you can see.
X squared plus 2x plus 1.
And let's square this one up here.
X squared minus 2x plus 1.
Okay. So, f of minus x is definitely not equal to f of x, right? So it's not even. Now, is it odd? Well, what would be minus f of x? That would be minus x squared plus 2x minus 1. Well, it's not that either. In other words, what we got when we figured out what f of minus x was something that was neither f of x nor was it minus f of x. So it's neither.
Okay.
In other words, it has to either be f of x or minus f of x for it to be one or the other. Let me give you another. First step.
What is f of minus x?
what is the cosine of minus x? Think of the fourth quadrant. What's cosine in the fourth quadrant?
Positive.
So that's the same as cosine of x. In other words, the cosine of minus 60 degrees is equal to the cosine of plus 60 degrees. Reference angle is 60 degrees in either case, and they're both positive in first and fourth quadrant. That's 1/2, that's 1/2. So what I have is f of minus x equals f of x, right?
Right.
F of minus x equals f of x for this function. That makes it even. And if I graph it, you can see, what should it have symmetry over?
No, the y-axis.
And it
right.
And
yeah.
it does. It has perfect symmetry over the y-axis. In other words, if I were to find a value for that point right there, and it's negative, it's the same value. At cosine of minus x equals cosine of x, always. Whether you're in the third and second quadrants or in the first and fourth quadrants, doesn't matter. Cosine of minus x equals cosine x, because it's even. And we can see that it's even because it's symmetrical about the y. Now let's talk about this function. First step.
What is f of minus x?
Now, what's sine of minus x equal to? Think again, fourth quadrant. What's sine in the fourth quadrant?
Negative.
So that's equal to minus sine of x. In other words, if I said, what's the sine of minus 30 degrees, our reference angle is 30 degrees, so the answer is 1/2, but it's in the fourth quadrant, so it's minus 1/2. So the sine of minus 30 degrees is equal to minus the sine of 30 degrees. Like that.
Okay.
Which makes f of x equal to minus f of x. Or excuse me, it makes f of minus x equal to minus f of x. That's odd.
Okay.
And the way to keep these straight is not to use sine and cosine as your basis, but to use y equal x squared and y equal x cubed as your basis, because that's even and that's odd. And once you figure out why that's even and why that's odd, then you can carry the logic over to trig functions.
Okay.
In other words, you don't have to keep track of whether cosine is even and sine is odd or vice versa. You don't have to remember that. You can always figure it out by remembering y equal x squared and y equal x cubed.
Okay.
Okay. Now, most functions are neither. If I say f of x is equal to sine x plus 1, well, that's not the normal sine curve, that's this sine curve. Well, that doesn't have symmetry over the y-axis or the origin. There's no symmetry over the origin. For something to have symmetry over the origin, pretty much it almost has to go through the origin, although that's not really true. let me draw another function that has, well, you tell me what this is. Is that even or odd? Here, let me write it properly again. I keep using y notation, but on this topic I should definitely be using f of x notation.
Yeah, it's odd.
Correct, because
if the x is negative, the whole fraction is negative.
Well, because of this. That's what you have to prove. Okay? And what is f of minus x? Well, it's equal to 1 over minus x, which is equal to minus f of x. So I get f of minus x equals minus f of x. That's why it's odd. That's what you always have to show. Now, if I graph that, I do have symmetry about the origin. Notice that if I took this part of the curve and reflected it over the y-axis and then the x-axis, I would have that. So I have symmetry over the origin. So that last statement I made, that it pretty much has to go through the origin, is not true. This does not go through the origin, and yet I have symmetry about it. But all I have to do is change one thing here. If I make this 1 over x minus 1, that does not have any symmetry. Notice what that does to my curve. Moves the vertical asymptote to 1, and now my curve looks like this, and I don't have any symmetry with anything. So, to prove even or odd, you must apply this test right here.
Okay.
What else, William?
So this next one, I'm foggy on this topic, so I'd like to go through it. But it's 5x to the 5th minus 9. And that's in the numerator of a fraction. And the denominator is 9x to the 5th minus 5. And, sorry, it's f of x equals that, and asking for the asymptote.
I knew that. I knew that's what it had to be because there's no way to simplify that. So it can't be anything other than what are the asymptotes. Let's talk about the vertical asymptote. How do I solve for that?
I do not remember.
You set the denominator equal to 0 and solve for it. Well, that's the denominator. First rule of math is you cannot divide by 0. So division by 0 creates vertical asymptotes, which can never be crossed. Okay?
Okay.
What's x equal to?
The 5th root of 5/9.
And it is not plus or minus. It is the 5th root of 5/9, positive 5th root of 5/9.
And is that because 5 is
odd? Yes.
Okay.
In other words, if it was x to the 4th, then it would be plus or minus the 4th root of 5/9. But if it's odd, then either it's an even number or an odd number. It's not both. Okay, so there's your vertical asymptote. So if we were graphing it, I don't know, did they want you to graph it, or they just wanted asymptotes?
They don't want, it doesn't ask to graph it.
All right, going to anyway.
Fantastic.
There's the vertical asymptote. X equals 5th root of 5/9. Okay? The harder one is, where's the horizontal asymptote? It's not really the harder one. It's actually the easier one. But you have to remember the rule. Where do horizontal asymptotes come when the highest power in the numerator is the same as the highest power in the denominator? And that's the only thing that counts. I could have a 9x to the 4th there, and it would not matter. It would not affect my horizontal asymptote. My horizontal asymptote is strictly based on the highest power of x in the numerator and denominator. If they are the same, like this, then my horizontal asymptote is the ratio of the coefficients. Y equal 5/9. Now, if I did have to graph it, I would graph it on this grid. In other words, these are always hyperbolic in nature.
Right.
This graph is either going to look like this, or it's going to look like this. It might be in the 2nd and 4th quadrants. It's always been hard for me to get a good feel for which one it is. Okay? Now, it's real easy to tell. What's the easy way to tell?
If it's positive or negative?
Well, you got to pick a value for x. And then figure out what the f of x value is, and you'll be able to determine whether we're looking at the red graph or the black graph. What's a good value for x to pick?
0.
What is f of 0?
9/5.
That's up there. The red is our graph. If it would have been a number less than 5/9, we would have known the black was our graph.
Right.
It clearly is 9/5, which is above our horizontal asymptote. That makes the red our graph. And if we did have to graph it, that's the way I do it. There may be an easier way, but this is the way I've always found to be the most reliable.
Okay.
Okay? Now, let me change one thing. Now what's the horizontal asymptote? 0. Y equals 0. In other words, if the bottom is bigger than the top, and when I say that I mean the highest degree in the bottom versus the highest degree in the top, the asymptote is always y equals 0. And it doesn't matter how much. If that was 6, asymptote still y equals 0. If that was 2, asymptote still y equals 0. The only time it's not y equals 0 is if they're the same. Then it's the ratio of those coefficients.
Okay.
And that applies to all. Let's just talk about this for a moment. In this case, the top is bigger than the bottom. Guess what? That creates an oblique asymptote if it's exactly a difference of 1. So I might have a grid that looks like this with a vertical asymptote right there. And then my function would look something like this. That would be in my 1st and 3rd quadrant. But alternatively, it might equally look like this. Have you dealt with oblique asymptotes? Okay, that's how you get them. Now, if this is 2 bigger, you don't have oblique asymptotes. You only get oblique asymptotes when it's exactly 1 bigger. And if you want the equation of that asymptote, what you do is the division. You divide x squared plus 10 into x cubed minus 1, and you're going to get a linear factor with a remainder. Well, you don't care what the remainder is. Well, it's not true you don't care, but whatever the linear factor is, let's say it was x plus 2, that's the equation of your slant asymptote. Now, the remainder is important in that if the remainder is, say, 5 over x plus 10, then there's a vertical asymptote based on that also. In other words, x could never be minus 10. So that would create a vertical asymptote. So there's really only 3 situations that you need to pay attention to. One is, say, this one. It doesn't matter what follows that. I wrote that in there even though it's immaterial. The only thing we care about is that. That is going to create a oblique asymptote automatically. That's going to be linear. It's going to be a straight line asymptote at some slope. In fact, in this case, the slope's going to be 1. Okay? Now, if I have this, can't do anything. You can do the division, but it doesn't mean anything with regards to asymptotes. The other possibility is that you have equal. Say I have this minus whatever, 300 x cubed, all over this, plus 1,000,000 x cubed. What's my horizontal asymptote? What is it?
-1.
Good. It's the ratio of those coefficients because it's the same power, and these make no difference whatsoever. And then the only other situation is where the bottom is bigger than the top. What's the horizontal asymptote there?
7/9.
No, it's always y equals 0. When the bottom, when the bottom is bigger than the top, it's always y equals 0. And here's one way you can figure that out, William. The horizontal asymptote is what happens to y as x goes to infinity. That's really what horizontal asymptote means. In other words, I told you how to get, a couple of different asymptotes, but in reality, let's say it was 7 over 7, and this was a 2, and that was a 3. So I'd have a horizontal asymptote at 2/3. But what that really means is that as we go to infinity on the x-axis, we approach that asymptote. Okay? So, if you ever had a problem like this, reduce it to that, and now figure out what happens to that as x goes to infinity. Well, it approaches 0, right?
Right.
As x gets infinitely large, this gets infinitely closer to 0. Which means your horizontal asymptote has to be y equals 0. And that's the case whenever the bottom is greater than the top. It's always going to reduce down to 1 over x. And as long as x is in the bottom and not in the top, it doesn't matter what that exponent is, this thing goes to 0. Which means your horizontal asymptote is y equals 0.
So, the concept of asymptotes, was that introduced by Newton when he came up with calculus?
I don't think so. I don't think so. Asymptotes are based on division by 0. So that's why I don't really think Newton did it. He might have. You never know. Newton did an awful lot. I certainly don't know everything that he's credited with. But if I have a function 1 over x minus 1, I necessarily have to have a vertical asymptote at x equal 1. Because first rule of math is never can you divide by 0. So that's always going to create a vertical asymptote as division by 0. Now, what's the horizontal asymptote on that function? What's the highest degree power in the denominator?
1.
What's the highest degree power in the numerator?
1.
Nope, 0. There's an x to the 0th if you want to think about it like that. In other words, the denominator wins immediately. So what's the horizontal asymptote?
1.
0. It's always y equals 0. If this thing goes to 0 as x goes to infinity, which it does, then you must have a horizontal asymptote at y equals 0. But the reason you have it is because the bottom, the denominator, is a higher degree than the numerator. There is no x in the numerator. That automatically makes the bottom the higher degree. But if necessary, you can think about it as there actually is an x in the numerator, but it's x to the 0th because anything to the 0 is 1. So if it helps to think about it, go ahead and put an x to the 0 in there, but you don't need to. If you have an x in the denominator and you don't have any x's in the numerator, then your horizontal asymptote is y equals 0. So this function is going to be hyperbolic in nature, and it's going to approach those asymptotes. Now, there is a difference between vertical, horizontal, and oblique asymptotes. Vertical asymptotes can never be crossed, ever. Horizontal asymptotes can. There's nothing in the world that prevents that bottom curve from doing that, crossing that horizontal asymptote. I can't give you a function that does that, but if you gave me a function, I could show you how to tell whether it crosses the horizontal asymptote or not. And you can also cross slant asymptotes. Yeah, or oblique. If I have a slant asymptote, my function could theoretically do that. It's always going to approach that asymptote as x goes to infinity, but there's nothing that prevents it from crossing the asymptote, oblique and horizontal. But you cannot cross vertical asymptotes, because if there's one rule in math that is everlasting, you cannot divide by 0. That will probably be the first commandment of math for 10,000 years and maybe a million years. or maybe even forever. It's hard to imagine in this universe that will not ever be the first commandment of mathematics, despite Newton's calculus. Newton's calculus doesn't really divide by zero. What it does is divide by numbers that approach zero.
Right.
It just confused him enough that he wasn't certain of it because it was so close to dividing by zero. All right, what else you got, William?
So the next one is polynomial long division.
Okay.
And it's 2x to the fourth minus 9x to the third plus 21x squared minus 26x plus 12 divided by 2x minus 3.
All right. First of all, notice one thing about the divisor and the dividend. Neither one of them is missing a grade of x. In other words, we've got x to the fourth, x to the third, x squared, x. Over here we got x. So we don't have anything that's like this. That would be missing an x term.
Right.
That being the case, we do not need any dummy variables. If we were missing an x term in either the divisor or the dividend, we would have to put in a dummy variable. If I didn't have an x cubed term, I would make a plus 0x cubed.
Right.
Okay? Now, these are not hard. It's stir and repeat. The first thing you do is divide that into that. What do you get?
X cubed.
Next thing you do is you multiply your answer by both terms. What do you get?
2x to the fourth minus 3x cubed.
As with all long division, it's subtraction. The difference between synthetic division and long division is subtraction, synthetic division is addition.
Right.
One of the reasons it's easier is because people have a lot harder time with subtraction than they do addition. But since they said you had to do this by long division, we're stuck with subtraction. Now, subtract the bottom from the top. What do you get?
You get negative 6x cubed.
Just like long division, we bring down the next term. Repeat. That's what I mean by it's strictly a repetitive process. Now we're going to do exactly the same thing again. Divide that into that.
Then you get negative 3x squared.
Next step.
Multiply the
Okay.
dividend by.
What should I write down here?
Negative 6x cubed plus 9x squared.
Okay. Keep going.
And subtract that, and it's 0 plus.
Those are always going to cancel out, and you know that 100%
Right.
certainty. If you did your division properly, they will always cancel out. In other words, when I divide 2x into 2x to the fourth, my answer times 2x better be 2x to the fourth. Otherwise, my division wasn't done properly. So when I get to that step, I don't even worry about anything. I just cross them out. Deal with the next term.
Okay.
Which is what?
12x squared.
Next.
And then minus 26x.
Stir and repeat.
And then it's up top, it's plus 6x. And then back down, it's 12x squared minus 18x. Then you subtract that, and you get 44.
No. Minus 26 minus a minus 18. That's why people have trouble with subtractions, because there's so many negative signs it blows their mind.
Yeah.
It needn't do that. Just always write it out like that, and now it's never complicated. What's minus 26 plus 18?
Negative 8x.
Plus 12. One last division is possible. In other words, we keep doing this until this last term is a lesser degree than our divisor. It's not yet. I can still divide 2x into minus 8x.
So then it's minus 4. And then negative 8x plus 12. And you subtract that, it is 0.
And that's actually key. That 0 remainder tells us a lot. The first thing it tells us is that that is a factor of our quartic polynomial. It's a 0. If somebody told you to find the zeros of that quartic, one of them would be 3/2. And that's a theorem in precalc. It's that if a polynomial has a rational or has a factor, then when you divide that polynomial by the factor, you get 0 remainder. If you get a remainder anything other than 0, then that divisor is not a factor of your polynomial. Straightforward as that. Now, obviously, if I multiply our answer by that divisor, I'm going to get that polynomial, because multiplication is the inverse of division. So if your life depended on it, if somebody said do this division, and if you get it right you live, if you get it wrong you die, you're going to do that step, right?
Right.
In other words, you're going to multiply those two things together to make sure you get the quartic that is in your dividend.
Okay, right.
And this is not a particularly good problem to do synthetic division on, which I didn't know till I recently tried it. Maybe it was with you even. You might think that all I'd have to do is solve for the 0, which is 3/2, and that I could then do synthetic division with 3/2 in the box and list my coefficients across the top. Guess what? That does not work. Does not give you the same answer. Notice the very first thing I dropped the 2 down. Well, I don't see a 2 up here. So you cannot use synthetic division in this manner, where there's a coefficient in front of the x. If it was just x minus 3, then you could. You could put 3 in the box, and synthetic division would produce the same answer as long division did. But if you have a coefficient other than 1 in front of the x term, you can't do it synthetically.
Okay.
You can do it synthetically with complex numbers, but you cannot do it if there's a coefficient other than 1 in front of the x term. You've got to use long division.
And that holds true all the time?
I believe so. Like I said, I didn't realize it until somebody gave me a problem the other day and we tried to do it synthetically. I figured you could do it synthetically because what goes in the box is the 0, right? Well, the 0 is 3/2. but it does not produce the correct answer. I think it produces exactly double the answer. So perhaps, yeah, I think so. Perhaps you can use it and cut your answer in half, maybe.
That's weird.
It is kind of weird. But for sure, the first term is 2, not 1. And then I suspect the second term, let's see, what would the second term be? Yeah, the second term is -6, which is exactly double -3. So if I were to do this synthetically, I would come up with an answer that if I cut it in half, in other words, if I divide by the denominator, I'll be okay. So maybe you can use synthetic division, you just have to know that little trick. Got 5 minutes. What can we cover in our last 5 minutes before your test?
Well, speaking of synthetic division, I have one of those.
Okay.
It's x to the 4th minus 3x cubed plus x squared plus 4x minus 5 divided by x squared plus x minus 2.
Wow, and you're supposed to do this synthetically?
Yes.
Not sure I know how to do it synthetically. Maybe by just dividing by the -2. Never had this problem. That factors into x minus 2 times x plus 1, but I don't see how that helps. It'd be easy to do by long division. In other words, first we have every degree of x represented in the divisor, and we have every degree of x represented in the dividend, so we don't need to use any dummy variables. So I certainly can figure out what the answer is, and the first answer is going to be x squared. Okay, so let's see what happens if we divide by I know how to do this by synthetic division. That's x minus 2 times x plus 1. So my first divisor is one of the zeros. When I get done, I'm going to do another synthetic division with -1 in the box. And that will work, guaranteed.
Okay.
So let's do this one. Give me the answers.
Just drop down the 1, multiply that by 2.
Just tell me the numbers.
-2 plus 3 is -1. And then -1.
Just give me the answers. Just give me the numbers to write. I don't care what. I just want to make sure you know how to do synthetic division.
Which numbers?
This one right there is where I'm at.
-2.
Okay. Below the line?
-1.
Up here?
-2.
Below the line?
2.
Above the line?
4.
That is not 0. That means this is not a factor of that. This quadratic is not a factor of this quartic. However, why would they do that? Because now it makes it really hard. It would have been much better if it was. Makes me wonder, did we do our math right? I think we did. William, I got a 7 o'clock appointment tonight. I am stacked up through tomorrow.
Yeah, no, that's not a problem. That's fine. I kind of know this is going to be on the test. It wasn't in our...
I've never seen a problem like this. Now, this problem would make perfect sense to me if these were factors of that polynomial. Because then I'd have a 0 remainder, and then I could do it again with -1 in the box, working off of those coefficients. And I would have my answer. It would be a quadratic. But when I don't get a 0 remainder, I'm not quite sure what to do next. My life depended on it. I'd go back and do long division on it. Because I know for sure long division is valid. Synthetic division is sometimes works good, sometimes works a little funky.
Okay.
Okay? William, good luck on your test.
Oh, thank you.
Have a good summer. I hope your allergies are better soon.
Thank you, Mr.
Are you a junior or a senior, William?
Unfortunately, I'm a junior.
Well, that means we'll probably be working together next year. What kind of math are you taking next year?
It does.
You're taking AB Calc, right?
Oh, no, statistics.
How come all of my students are taking statistics? I do not do statistics. I got 3 pre-calc students that are all signed up for statistics next year. I do not do statistics. I'm sorry, I just don't have the I don't have the expertise in it to tutor it properly.
That's very unfortunate.
I know enough statistics to handle beginning statistics that you get in Algebra 2 and pre-calc and stuff like that, you know, median, mode, mean, standard deviation, all that good stuff.
Right.
But I do not have the expertise to tutor somebody that's actually taking a statistics class. So you might, I don't know, I'll leave it up to you. If I were you, you have enough math skills that I would think you would be a potential STEM person.
Oh, God.
Well, if that's true, you should be taking pre-calc next year. Or calc. You took pre-calc this year. You should be taking calc next year.
I should.
Why are you not? Anybody that takes pre-calc, unless you're getting a really bad grade, or are you getting a good enough grade that they would let you take calc?
Yeah, I have a B. So.
Calc is going to be so much more impressive to any college administrator than statistics will be. Trust me.
Okay.
All fast-track students end up in calc. Who ends up in statistics are people who have faltered in math.
Okay.
College administrators know that. So if you want to impress a college administrator, just take calculus. You'll either get accepted or not by December or January. So, you know, I mean, if you can get through the first couple months of calculus, you'll be fine.
Right.
And I can help you. I'd say that I can help you do as good in calculus as you would do in statistics on your own. Now, you might find another tutor that does do statistics, but I don't. So.
Okay.
Okay? Keep that in mind. But either way, have a good summer.
Thank you, Mr. Town. You too.
You're welcome. Thanks very much. Talk to you later. Bye, William.